I'm here to talk to you about a topic that's very close and dear to my heart, REST beyond the obvious. I talked about, or in the keynote yesterday, I talked about something very technical, very low level, reactive database access. This noon, I'd like to raise the abstraction level on to some more conceptual thoughts about designing APIs and the influences that might have changed when doing so in a microservices area. I'm not too much of a fan of that word, actually, because it just seems to put so much focus on size, but it's actually about cohesion within these services. But just to get this out of the room, my name is Oliver Gierke. I'm working on a Spring Data team, building the Spring Data APIs, basically persistence APIs for Spring Framework, or on top of Spring Framework for different data stores. Besides that, I'm very much involved into architectural discussions around domain-driven design. That sort of comes from the repository abstractions in there, and that leading into RESTful APIs. So before I actually did that, I've spent a lot of time with customers and building APIs. I still continue to do so from time to time, but that's sort of the context that I work in. REST. So who of you has read the dissertation by Roy Fielding? That's not too many hands, right? Actually, it's quite a readable piece of text, especially compared to other dissertations I had to read. And like trying to summarize that, I'm definitely giving or avoiding some details here, but fundamentally what it's all about is that when you design like networked systems, client-server systems, from the options that you can choose from, Roy identifies some constraints for, and then derives some traits of the architecture that's resulting from you following those constraints, right? And that's kind of the interesting step in here is, I think, is to realize that constraining yourself can actually have positive effects on what you're actually trying to achieve. If you think about it like less of the REST context, we usually these days constrain ourselves to build a piece of software that's buildable all the time, right? That's why we're doing continuous integration, actually. And that's a constraint we put up on ourselves that requires work. But the net effect is that we can actually move faster because we don't have to constantly work with broken software, basically. And that's kind of a thing that really strikes me a bit hard to understand in the first place, maybe. But it's something that I'm going to get back to in a couple of minutes. The trait that I'd like to center this talk around, because it's subtitled API design for ever-evolving systems, is evolvability. And why is that? We split up systems or build microservices these days to why do we do that? We do that to achieve velocity in our businesses, basically. We want to be able to ship features faster. We want to ship new features faster. So we want to basically be able to move quickly when looking at an individual system. And we split, let's say, a monolithic system apart, or something that we would have built as a monolithic system a couple of years ago, and try to basically do that in smaller systems and individually working teams, really. The thing being, what's weird about, nothing weird about that, but when I see this kind of taken into practice, teams are often very focused on being able to build something quickly in the first place. But if you think about it, this is actually not what we wanted to optimize for. We wanted to optimize for being able to deploy stuff quickly, like all the time, right? It's a very forward-looking goal, actually. So I see people or teams often trapped in basically them trying to basically start with that and then looking for the new hot framework out there that allows them to build, let's say, a new service in 30 minutes or 45 minutes, right? Build it tiny, build it fast, be done with it. But the real challenges appear once you actually have that in production to actually change the stuff and still not break any other of the clients, right? Especially if in a scenario where you have systems that split up that way, you end up with like relationships between the two. So usually one service that's providing an API is not only having a single client that's actually using it, but multiple ones, right? And if you break your APIs in that server, it creates effort, and a lot of effort, in these individual clients. We're going to get to, back to that in a second. There's 3 big sections that I want to cover in the next, hour still? Context, abstraction, and coupling. So let's start with the first one. I want to have a brief look at basically the history of, okay, how did application development sort of change over the last years in the context of APIs? Because that pretty much shows why we build APIs the way we build APIs these days, right? So if you're as old as me, then you might actually remember the time when we had these green boxes on the server. So we had server-side applications, right, that had some kind of application logic buried into them. They were interacting with a database. And then we had some piece of software called a web framework. It wasn't something like living somewhere else, but that actually lived on the server. And then it was producing HTML. That HTML then was sent to the browser, and the browser did nothing but actually display that. It would render the HTML directly, and that architecturally that meant that the entire business logic was living on the server. It was living in exactly one place, and the browser would just basically dumbly displaying that. And then we got, you also have to think about it, that was back in the days when internet connections were very slow compared to these days, which often sort of bothered us when each invocation, each form submission was sort of resulting in an entire page refresh, right? So you have to reload the entire web page over a slow connection. That was kind of like, meh. So we were thinking, okay, what if we could not have validations? Let's say we have to enter a credit card and there's some structural validation or email addresses. Why do we actually need to go to the server to do that? Couldn't we just actually do that on the client in the first place, right? Or at least, and that's where the interesting part starts, at least pre-validate it. Because what people often think of what they're doing, and that statement that you usually get as with the advent of more extensive frameworks like Angular and whatnot, that they're sort of moving business logic to the client. And in fact, that's not really what's happening here. What's happening is that we replicate some kind of business logic into the client. So we create a copy of that we effectively have to keep in sync, right, with the server side, which for web applications is not necessarily so much of a... Does that work with those dropouts, or shall we switch to... Is that okay? It feels like I'm on the audio. Can I get the handheld mic maybe, if that works better? It's pretty, because otherwise I have to sort of repeat every other sentence. Right, so that is not that much of a problem if you assume that sort of what's running in the client and what's running on the server is sort of the same thing. In other words, whether it's controlled by the very same team, right? That's the first aspect that sort of might mitigate this issue. But that story actually changed over time as well. So that's what I was basically trying to say. Sorry, does that work? Oh, wow. I feel like a host of a comedy show or anything. Anyway, let's hope we're not turning into one. Right, so that being are you in charge of the client? Okay, back to topic. So that's still fine if you control the client and it's sort of built with the same team. But now, as I told you before, this was kind of from let's say 10 years, the way we built server-side applications 10 years ago. Because nowadays, oftentimes the web front end is even considered a separate project, right? It's written in a Node or what have you, or an Angular application effectively often is maintained by a different team. So that already creates a slightly different picture here. Where did I put here? Sorry. So if the front end is separated from the back end in terms of like teams, you already get into an issue where you sort of have to coordinate releases, right? So if the server-side team that's actually maintaining the business logic and let's say is sort of defining the rules in which validations and whatnot have to actually be performed, then they have to constantly sort of communicate with the client team. And if the client team is co-located with them, that might not be a big of an issue, but you oftentimes have to do like to coordinate the releases, which is something that might be okay for a web application, but the picture gets more complicated because we're entering the age of mobile, right? So I'm not necessarily talking about like mobile-first websites, but actual new clients to that maybe very same API in form of an Android application, of an iOS application. And you can see that with the number of clients that sort of depend on that API, the effort to replicate and to keep those rules in sync increases, right? That's probably not too hard to imagine here. What often plays into this is that with the APIs that we sort of expose on the server side are considered like data providers to those client applications, which is kind of a weird thing to think of because you still need to validate stuff on the server side, right? Even if it's just like, if you have a relational database and you have foreign key constraints in there, you can't just like take arbitrary JSON and then throw that into, let's say, a Redis and never care about it again. I mean, you could do that, but in fact, there will be validation rules on the server, and it's kind of sort of weird to not actually expose these business rules in a slightly, let's say, more advanced way to the client. So with these mobile applications around, let's say, even if we assumed we can sort of like coordinate the releases of these applications between the server-side team and the client developers, we're not really, for mobile applications, we're not really in charge of the deployment anymore, right? So the difference here is that with a web application, with let's say an Angular application, you can just like press F5 or Command R on your browser, and you basically get the latest version of that thing. So there's a very tiny time gap here. But with the advent of app stores and whatnot, even if you release the new clients, you're not really sure. I mean, it's immediately available. You're not really sure that people actually install it. So there's kind of like all these things come into play and all of a sudden complicate the picture, which is completely different from if you think about it, like when we built on the very first model, right? We were just building an application and we had users sitting in front of them and using them, right? So there's all these requirements that basically are effects of that split up are pretty new to the overall architecture. Something that you could sort of or that basically plays into the discussion is the apparent distinction between front-end and back-end services. So I get into client or team discussions where they basically say, okay, yeah, we see that this is a problem for the front-end, but for the back-end services that are talking to each other, that's not that much of an issue, right? Because we can actually just talk to the other team and then basically communicate a change that we make to the API, and then they will pick it up and what have you. So that's sort of assuming that we're kind of or if we assume that we live in a world, let's say even in the back end, of services communicating with each other, it's usually not staying with 3 services. I mean, you don't have to do the Netflix thing necessarily, but you very, very likely to end up in a situation where you kind of have a growing ecosystem of services in your company that sort of have to interact with each other. Right? I'm like using API calls here. That could be a message broker. The actual interaction pattern doesn't matter too much here. The question is, if you have, or if you're basically, if you have that kind of context, do you really want to know about all the other services, right? So the fundamental argument in the first place is, well, I know that these other 3 teams are using my API, so I know who I need to talk to when I want to change stuff, right? It's also coming from that, or the entire idea of consumer-driven contracts is basically assuming that we know who is defining the requirements for our API. But in a world that looks like, okay, you have like 30 services and 30 teams in your company that sort of write services that have to interact with each other, is that really a reasonable assumption? Is that something we can or we should assume? Right? So the question I'd raise here is like, aren't you better off with actually not, I'm not saying you shouldn't be interested who's using you, but would you actually want to be in a position where you sort of have to know your clients to actually basically deploy changes to them, like far-reaching changes? And that ultimately leads to, I just basically talked through this to make the point that in a system of systems scenario, being able to evolve an API is a very fundamental aspect that you have to think of when designing them, right? And first and foremost, because of the fact that you will definitely have 1 or even more clients of your API. I just like advocated for not wanting to know how many that actually are in terms of design. Which means that every change you make to your API, if it's a breaking change, if that means let's release a new version of that service, I'm going to get to that in a second, that will ultimately multiply the effort in your client systems. And coming back to what I said earlier about the being focused on the evolvability instead of being focused on building something quickly, that effort is basically exploding. So sometimes it can be worth spending more time on something when you develop the API on the server side, instead of choosing the quick and dirty, oh, that's easy to do using that tool, rather spend like a couple of minutes more when actually implementing the server side to save some time in the client teams, because that's where basically the explosion of the effort is coming from, right? So keep the amount of work to the clients to pick up your changes to a minimum. That's the kind of idea, and we're going to have a look now at like what the fundamental underlying mechanism for that is, and how you can actually implement that. Abstraction levels. I've borrowed a slide from Stefan Tilkov here. He's like a quite well-known guy in the REST world. He had a talk on microservices patterns and anti-patterns. He was talking about the abstraction levels on which you can actually integrate different systems with each other. And he's a big proponent of something called the self-contained systems, which is the idea of building web applications that then are mostly interacting or just integrated via the UI by just clicking that phenomenon called a link, which is surprisingly simple and effective. So just imagine Amazon, right? If you're browsing the product pages and if you're going to your own, let's say your account details, you're actually switching to a different application by just following a link. You're not necessarily, it's not immediately obvious because they just both look the same, but that's kind of the idea. And that's basically where that slide ultimately leads to. And it's actually not where I'm trying to get at, but that this sort of translates into basically the abstraction levels that I've seen people have their APIs at. And it's interesting to actually see that mapping really well here. Because, I mean, what's the easiest, apparently the easiest thing you can do is you could try to say, okay, I have this database table and I want to actually make that data available to another service. So I basically take every table, and every table gets its own HTTP resource, and then you can make like a put call to insert something, and you can make a post call, a put call to update something. You can make a delete call and a get call to get something. That's this CRUD-ish kind of HTTP or CRUD via HTTP paradigm, basically. That's fine, but if you think about it, what's the CRUD version inside a Java application? It's basically a repository, right? Spring Data repository, hopefully. And imagine, or think about it, where does the business logic live when you have implemented a repository? Where do all the verifications live? In the service layer, so in front of the repository, right? So if you now take the time to actually use that abstraction level and lift that up to your HTTP API level, what does that mean? All the business logic is pushed down to the clients, and then following my arguments before, it basically means that you have to replicate all the business logic in all these different clients. We're going to look at an order example that you've probably seen before when you've been in any of my other talks, but just the question when an order is allowed to be canceled then has to be sort of implemented in front of that API, right? And I think I have a slide on that in a second, but raising or putting up that low abstraction level and putting that on the HTTP level is actually adding some cost to every call, right? Because if you do that, you sort of usually end up getting into, or there's some incentives to try to do very, very data accessy like things like, oh, I want to filter that collection of customers, right? And that basically often leads to people asking me to put some kind of SQL statement into some HTTP call, right? Which is a bit weird thing to see because that's a very expensive way to execute SQL, right? HTTP connections, right? So that's one thing you can do. You can do better if you sort of try to embed some domain knowledge that you have that's not necessarily obvious from the database, or sometimes it's just not available in the database, and try to shape your API around that. So let's stick with the order example. So we have an order that has line items, and the orders are placed by a customer. And let's assume the customer is a separate aggregate from that order. Order and line items, one aggregate, customer is a separate aggregate. If you think about the way that this would, for example, end up in a relational database, there's no way for you to actually, looking at the database only, so staying at the level below, there's no way for you to actually find out about the aggregate boundaries, right? Because the relationship between the line item and the order is a foreign key. And the relationship between the customer and the order is a foreign key. So when you start to basically model your resources and ask yourself, okay, where does the representation, what do I include in the JSON? Then like the level below is kind of hard to reason about because that knowledge is just not embedded there. On the domain logic level, if you let's say use Spring Data repositories and build a sort of domain model with your entities and aggregates, we could actually, and that's what Spring Data REST is doing, sort of reason about exactly those aggregate boundaries and create better default resource representations. The thing to understand here is that Spring Data REST is not a tool to actually throw at your Spring application and then, oh, there's an API resulting from that, I'll be done with it. Right? Because you just end up at this kind of abstraction level, which still means that without doing anything else, anything on top of that, it's basically having the same effect. All the business logic is living in the clients then, right? So you just know which aggregates to interact with. That might make things easier. We're using a little bit of Hypermedia to actually point to other resources, but it's a step up. It's just not necessarily changing the picture that much in terms of avoiding the leakage of business logic into clients. So what the really interesting abstraction level, and that's what I basically will try to focus on for the remainder of the talk, is that process flow level. So that abstraction level where you really think about, okay, what are the business rules that are
that sort of make up or the rules that make up my business, basically. So what constraints are given for placing an order? What can I, once that order is placed, what can I do to it? Can I cancel it? Can I move it forward? What have you? So thinking about the domain in that way, and actually trying to find means to express exactly these business rules in your API, right? And you see that we sort of have to get away from, oh, I do this get call and get back some JSON, and then I change 2 properties about it, and then I basically put that back to the server, because that's kind of like creating exactly that coupling. And we'll discuss basically that level in more detail later on. The slide completes with, that's why I mentioned it before, with Stefan's suggestion to build like web APIs and web applications and sort of linking them together. That's a bit unrelated to this thing here. I just wanted to not steal parts of his slide, but just copy it right now. So the third level is the interesting one for this talk. I wanted to summarize the last slide, or the essence of that, by this one here. So the one argument I usually hear when discussing API design with client teams is that, yeah, but if we keep it on that low abstraction level, then we can sort of, we can cookie cutter the clients, right? Because they just know, okay, the person or the customers live at the /customer resource, and then they can get put post delete on that. And the accounts live on the /accounts resource, and they can get put post delete on that. So that's fine. That's probably very easy to build, remember. That might even be easy to actually build some generic client API for that. But if you put that generic API into your clients, then again, ask yourself, where does your business logic live? Behind that, in front of it. So the tricky bits are still then left to the clients, and that's actually creating the coupling. Not necessarily the coupling between the client and the server, but between the individual clients, right? The iOS application has to work with the same rules than the Android application. I mean, you might accept tiny differences there, but fundamentally, core business rules must sort of be in sync all the time here. All right. So what that kind of model, if we summarize it again to where does the business logic live in, let's say, in most APIs I see today, then that's basically, it's looking something like this. So you of course have the data on the server. You have little bit of domain logic. It's basically what's left of the business rules when you started trying to move stuff into the client, right? But a little bit like validating core constraints, validating that the email address is an email address, validating that the customer is linked to from an order. That's stuff that's still on the server, but everything else is mostly on the clients and then again replicated amongst the clients. So I'm kind of wondering, so I'm kind of wondering, what if we, oh wow. That's a what if we could actually change the picture to that? So what if we could actually prevent that leakage of business logic into the clients? Because that would make our overall lives easier, right? So I'm sort of repeating myself, but I hope you get the point. The less logic we have, the less business logic we have in the clients, the less work it is to actually change the business rules, because we're just free to do it at exactly one point. I mean, that's kind of, it's fundamentally even, it's code organization, right? You wouldn't want to like have the same, let's say even in Java code, the same piece of code flying around everywhere. So it's kind of like the dry principle, sort of. So we want to prevent the coupling. We want to prevent coupling between the client and the server, because that sort of is, or promises to actually give us some leg room to move the server and the business logics in the server for quite a bit. And so where is coupling coming from? It's coming from parties agreeing on something, right? So if let's say marriage, right? Coupling. That's even funny because there's the word couple in there. But I'm getting distracted. Not sure why, actually. The fundamental principle of coupling is to agree on things, right? We want to define things. And let's take a step back because I just mentioned Java code. What does like coupling look in Java code? It looks, or it's, if you think about it, take a step back. Let's say we have this kind of Spring Bean there that has a method that we can invoke, and then we have a return type that's basically a promise that we sort of will receive an object that fits that structure. In this case, it has a so there's a user account being returned, and that user account has a salutation, right? So, and that contract is checked and enforced by the compiler, which is a cool thing because we can then go ahead, and that's basically the thing I want to get at. If we add a new value to the enumeration, so let's say we want to move from Mr. and Mrs. to actually add a professor in that enum, we can actually freely do so. And why can we do that, actually? So I could now go ahead and return from that create method, I can return a user account with a salutation of professor. And the client would not break, right? Why is that? Because they're pretty co-located, right? I'm assuming for now, let's assume the client code is actually living in the same compile space. So we have that party that actually checks the contract, that verifies the contract, is part of the same compilation space. That means we can use all sorts of tooling, kind of refactoring tools. We could even rename the method over there, and it would automatically be picked up by the clients at the very same time. Things get already a bit more complicated if we basically have two compile scopes, right? If that sort of code would sort of live in one compile scope, so let's say there's some kind of library and we have some client code that's sort of supposed to compile with that. If we change that server quote-unquote code, that way, if we added that value and we had a client that was kind of like compiled against the old version, you see where I'm getting to, and we would return, it probably would work fine unless we returned a professor as salutation for a certain value, because then all of a sudden that value is unknown to the client and it would just break, right? So there's two things that I'd like you to realize at this point, is that sort of the degree of co-location matters, and that ultimately influences what we can actually do or what we should do when it comes to specifying what a client can actually expect us to do, right? Because if you, let's get back to the REST world, if we went ahead and moved that sample up to the API layer, and we'd have, let's say, HTTP resource that's supposed to return that user account, and we throw $tool at that API because it's so convenient. Actually, just use a tool to let it inspect my code and then derive some API description from that, right? So it would come up with something like that. It's sort of, in case you haven't seen a JSON schema, so it basically say our user account is an object with a property of salutation that has an array which is constrained to string values, in this case, Mr. and Mrs., right? And if we have a description of that API that's so detailed, and hint, hint, it's actually leaking implementation details, that creates quite a few incentives to then on the client side do what? Code generation. Right. There's this quote from Kevlin Henney saying, code generation so that you can do the wrong thing faster. I should have put a shout out to, hi Kenny. Kevlin Henney, yeah. So that kind of, it's sort of, we're trying to make our lives easy on the server side, and then the client developer is just like, okay, if that information is here, then why shouldn't I not use it? I generate some code because I want to make my life easier. And then let's have a look at what happens if we now basically add that enum value. Because I've heard you can always add things to APIs, right? Isn't that what they say? So what happens if we change this to that and not recompile our client-side code and we return prof in the JSON? It's kind of blowing up the client, right? And there's a couple of things involved here. I mean, it wouldn't blow up if the client hadn't assumed that this is some kind of static thing, right? There's some dynamicity to that enum that we sort of did not properly convey to the client, really. So we didn't make it aware. So if there had been a way that we could describe, oh, by the way, the salutation is some kind of list of predefined value, and dear client, by the way, you can actually get the values that are currently valid from that other resource, or here is the list of values that are currently valid, right? Then it might have been just like written in a way that it had to pick up these values dynamically in the first place. But that's stuff that you actually only find out if you like really think about this stuff and not like try to throw a tool at it and hope that you can actually get something out of that quickly. So was trying to boil this down to the idea of, okay, always reflect of whether, I mean, I can totally see the appeal of the Swaggers and the Ramels of the world, definitely, and there's a lot of value to them. It's just that you have to basically double check if what you're doing here has kind of leaked some implementation detail and might create a coupling that you're not even aware of in the first place, right? Fundamentally, what I'm kind of wondering, or again, I've sort of derived that from the way we define Java APIs in the first place. And in this case, we're sort of getting to the idea that in the Java example, where we have this strong co-location of involved parties, that strong coupling actually has a very strong benefit of being able for the compiler to reason about the relationship, to change things using the refactoring tools and what have you. What just strikes me as odd is, so we accept that coupling because we get some benefit for it. What strikes me as odd is that we sort of basically repeat the same pattern, the same approach of defining API contracts in a case or in a context where those parties are not actually co-located anymore, right? It's not even a question of jar files in separate versions. It's a question of like teams and remote communication. I mean, it could be teams for jar files with different versions as well, but it's kind of weird that we do the same thing and expect a different outcome. Right? As if that promise, oh yeah, we build loosely coupled microservices. As if we just like chop that thing apart and then we, by the virtue of what, actually get low coupling. It's kind of a weird thing, actually. The underlying mechanism, the stuff that I sort of try to get to, is a thing called connaissance. Has anyone ever heard of connaissance? Not. So if you learn something today, it's connaissance. That word basically crossed my path in a talk by Jim Weirich, unfortunately passed already, in a talk that I would have never assumed to actually find stuff like that in. The Grand Unified Theory, it in turn gets back to a book by, what is it, this guy's name, Melia Page Jones. And it basically defines, it's sort of, connaissance is basically a degree of coupling, and it sort of defines the degree of coupling by raising the question, okay, what do you actually need to do if you have like two parties that were born together and you want to change one? What does it take to actually keep these things working? And there's a couple of, or the gist of it actually is that for more co-located involved parties, you can actually have higher degrees of coupling, higher forms of connaissance, and they will still be beneficial to the overall construct, whereas with more distant involved parties, you sort of have to move down basically the strength of connaissance to actually be able to keep things moving, right? To change things. So there's a higher cost of change associated with high degrees of connaissance and remotely related elements. So there's some spectrum here that's basically saying, okay, just to give you an example of the difference between the two. Let's say we can stay to Java methods. If you have a language that, like Java, where the position of the parameters of a method actually has semantics, right? So we have to put in, when we call a method, we have to put in the parameters in the very same order that it's defined on the provider side of things. Then you're basically are you up there, right? In the connaissance of position thing. If you get to named parameters, find a language that actually has that. Kotlin has it, right? Python as well. Thanks, Greg. You can actually change the order of the parameters. The order of the parameters doesn't actually matter because the client, when it's calling that method, has to be explicit about these parameters. And the interesting thing is that it sort of requires the client to do slightly more work, slightly more technical work by explicitly naming out the parameters, but that results in the ability to change stuff on the providing side of things, really. All right, what's the usual answer to actually, let's say, bigger changes that stem from, let's say we've sort of defined an API, or getting back to my example actually, what if I want to introduce that new professor enum value to an API, and we would actually break clients with that? It's versioning, right? So it basically boils down to this thing here. And the issue being that an approach like versioning works fine when you're building kind of libraries, because there's not that much cost, at least as a service provider. It's not much cost associated to doing so, right? You're just like, okay, let's change the version number. Let's say make it the 1.5 becomes a 2.0. And it's also there's not much cost associated to just keeping the old version around. I just put them on Maven Central and then Sonatype deal with it, right? So there's nothing, if you think about it in terms of like APIs and services, there's like one is that you sort of on the server side have to still keep these things around and running. So that might just produce cost. And that sort of like creates the incentives. Okay, at some point I want to basically shut this thing down, which again leads to the fact that you sort of then have to know who's actually using you, right? And that's something we wanted to avoid, as I said in the first place. And just conceptually, it's kind of odd. I mean, I get into these discussions quite a bit. We get into the Hypermedia discussion. How much time do I have? Okay, we get into the Hypermedia discussion in a bit, and sometimes when I just give talks about Hypermedia only, people step up to me and say, "Oh yeah, we don't need that. We have like REST services that basically just don't use Hypermedia." But by the way, what kind of versioning strategy are you suggesting? It's like, okay, you sort of have like decided to not follow one of the constraints of REST, but still are basically running into the lack of doing so, resulting in you having a challenge, right? So REST promises evolvability, but only if you follow the constraints that actually make it up. So I'm not even saying you will never be in the situation to actually produce a new major version, but oftentimes I see teams not actually trying to build a system in a way in the first place that allows them to actually more freely deploy changes to it. So what can I do to actually make a breaking change less likely? Is that what the quote says? Sort of, right? So it's already out there. It's been there for quite a while. Yeah, and that's fundamentally leading to the idea that if you build a new version of a system, just like I sort of advocated for not trying to distinguish between front-end and back-end systems and trying to sort of, this is special so I can do other things. It doesn't really make a difference, like deploying a new version of a service is conceptually not that different from just deploying a new service at all, a new completely other service that's dealing with a completely different domain. It's just by accident replicating 90% of the functionality before. So everything, basically all the effort it takes to like deploy a new service and document it and stuff is sort of replicated. So you're building separate things basically. There's a great write-up. This guy called Jacques Dubray, he had a research project on what kind of cost is associated to different versioning strategies. For versioning strategy, in this case, mean strategies to evolve your API and the effects of those. So the blue one is basically we have breaking changes in every new version that we deploy, and the green line sort of is version 5 can still serve clients that are compiled against version 1 and version 2 and version 3, so they're completely backwards compatible. That cost, of course, and that's something that people often overlook, includes the work of adapting the clients, and if it's multiple clients, then adapting all of those to the new versions and actually bringing them up to the latest version, basically. Because if you think about it, is there any new business value to a client in actually just like, okay, we can sort of adhere to the new API because the old one is shut off. We're not even interested in the new features, but we have to do work just to be able to keep working. That's kind of something at least I would like to avoid, really. So or there's some you probably guessed that. There's some concept that's often overlooked in API design that is really helpful in achieving that evolvability, and it's kind of crucial to it. And it's hypermedia, and it's even hypermedia. And I have a couple of slides later on. There's hypermedia and late binding. I'm going to get into that second aspect in a second. But what is hypermedia in the first place? We, instead of just sending you a JSON that says customer first name, last name, address, yada yada, instead of just giving that the client and letting the client figure out what it actually can do with it, or in the first step, in what kind of context that actually lives. I always have to cringe a little when someone talks about REST endpoints, because that's like the way that REST resources are usually implemented these days are really that they're endpoints, because you go there and that's basically the end of the internet, right? So it's kind of no links anymore. You can't go anywhere, like a dead end point, basically. So the idea is that we turn these endpoints into crossroads, basically, because we go there and then you can actually find, that order is associated to a customer, so you can actually find that customer over there. And it's already that is a tremendously powerful thing, because if you think about it, the client, the fact that it can just like take that URI and resolve that other related thing is something extremely valuable if you're basically chopping up systems and into like differently sized systems, because the client doesn't actually have to care whether it's talking to one system or whether it's talking to 15 systems if you just like send them the URI. So in the very beginning, let's say you start very monolithic and the orders and the customers are co-located, and it's by accident just the same server in that URI, right? And later on you basically decide to extract that customer service into a separate system, and then the old system just continues to send down the very same stuff, but change the server part of the URI to actually point to that other system. And the client would just pick it up without any other notice. Bless you. All right. So that's kind of a static thing, right? So we statically sort of link to other things, which allows me to explore that thing. But there's this infamous Hypermedia as the engine of application state. That sort of takes this thing a bit further, and it basically is kind of getting to the idea that we could not, or we could assume that these links are not static. We could put links in there that sort of represent the state of the resource. And if you think about it, it says REST, representational state transfer, right? So we get representations, and we transfer a resource from state to state. That's kind of it. So we could sort of agree on, dear client, whenever you're allowed to actually do something, I'll put a link with a certain name into the representation. And then the client could be built in a way that it says, okay, I literally, if JSON underscore links dot cancel order, then display button, what have you, right? So that's basically the idea. To quickly reiterate on that on an example is, you might have seen that before, I use that a lot in other presentations. There's this RESTbox example taken from REST in practice. It is a Starbucks-like coffee ordering experience where you basically place an order and then you can either pay for it or you can cancel it. Then when you pay for it, it's basically prepared, and then you walk over to that counter and wait for your drinks to be served. Imagine the Starbucks app actually provided some UI for that kind of an API, so that you can basically say, okay, I know there is a store down the street. I mean, in the US, you usually don't have to walk like for more than a minute to get to one, but let's sort of pre-order a couple of drinks and then just go there instead of walking at the shop, waiting at the shop, right? So fundamentally, what you see here is that oftentimes these APIs or these when you lift those business processes to the web, they have to sort of start to look like state machines, basically, and that's again representational state transfer, right? That's kind of expected in a way. So if you model these things in that way, it's usually a good starting point to actually build a nice API that actually lives on the same abstraction level. That's the interesting bit here. Because if you're just like briefly looking at it from a very high abstraction level in terms of understanding REST, you kind of wonder, REST is HTTP methods and resources, right? I mean, how am I actually supposed to have a state machine in there? It's kind of like, And the trick is, I mean, and with that, let's say, beginner's understanding level of REST, you'd probably come up with something like this. And again, this is like due to all these tools operating on a very, let's say, low abstraction level, they sort of produce things like that. So you get a sea of resources, and let's say you have the HTTP method documented, you have a lot of resources, and sort of some description what that's actually doing. What's totally missing here is, and I guess you have seen documentation that looks like this, is how do I actually achieve something meaningful with all of that? Like, right, I want to order some coffee, and I want to complete that order. What do I do? What do I need to do? And then you click through all the resources and you say, you can put to that and you can post to that. And what's totally missing here is all the conditional bits. So everything that's like cancel order only if in payment expected. Because this is where it actually gets interesting, right? And so assume just we have that default structure here. This default structure, just that kind of structure. So we have an order that there's some JSON coming back, and it has this kind of status of payment expected, basically indicating that we now have to pay for the order, right? And that's the state. Like it was, I think, the first one, so in which we could still augment the order, in which we could cancel or basically proceed with the payment. So the fundamental question is, in that kind of state machine, how does the client actually know when it's allowed to, let's say, cancel an order, right? So the first, and that's what, I mean, without any further knowledge, if you document your services that way, the only possibility the client has is to inspect the payload. So okay, then you have some code that's saying, if status equals payment expected, then display cancel button. Pseudocode, right? So along comes the business unit and says, guess what? We want to roll out that Starbucks application to Germany as well. And then that now we should, so instead of seeing payment expected, the Germans should see something like zur Kasse gehen or whatever. You see that you're not really affected here, right? But the development team is. Because if they now change the status field for the Germans to zur Kasse gehen, then they basically break their all the clients, right? Because then it's just a different string in here, a string showing up in the payload. And that's actually an interesting aspect, because oftentimes people think like the bad coupling, there's good coupling and there's bad coupling, right? If you want to achieve no coupling, then just don't let systems talk to each other. That's the most consequential way of doing it. But people are coming to me and saying, yeah, but my domain object has this first name thing, and my API will have a field called first name, and on the client I will have to know about the first name. So isn't that some kind of coupling? Of course, this is, I mean, I wouldn't even describe it as coupling. It's just the domain being expressed in different parts of the software. That's just it, right? And then you can still have, let's say, means to actually soften changes to that, and by being able to map between the parties. But actually, just relying on the presence of a field with a certain name is some sort of coupling, but it's not really problematic coupling. Problematic coupling comes from clients inspecting the right side of the key value fields, right? Assigning semantics to that payment expected thing that wasn't really supposed to be embedded in that, right? Nobody really, I mean, it's leaking business logic. In other words, the fact that you can only cancel while it's in this state into the client. And it's a weird form of replication of exactly that business rule. So what do we do about that? We could try to hide that decision from the client, right? We could, in the first place, and that's quite important, we could not actually tell the client that this payment expected thing is something that's sort of stable, right? So we could, because it probably on the server side will again be some kind of enumeration that is payment expected, then it's like preparing, and then it's being taken, and then it's being completed or something like that. We could not even like tell the client about that. We could just like basically pretend it's an arbitrary string field, right? Don't make any assumptions about that. And then we could put in a link into that representation and basically tell the client, dear client, here's a link I name cancel, and if that link is present, you can actually play that button, and if not, you just don't do it, right? So basically what we're kind of switching our documentation to is we remove all this kind of listing of resources, but instead get to something like this, right? We go ahead and say, okay, there will be different links in the payload. They will have dedicated names, and if you find a link named like this, then you can actually execute an HTTP call to the target of that link using that HTTP method, and you send around this payload. Again, the payload is, there's the structure of the payload is fine to know and fine to sort of bake in the clients. There's a couple of approaches to prevent some stronger coupling there, but let's leave it at that for now. So it basically just then changes the structure of the payload to something like this. So in this case, it's HAL, a Hypermedia application language. So that sort of defines what links look like in a JSON data structure. And then you can literally go ahead and implement a client that basically just like says, if _links dot cancel, then display button on button click, perform HTTP requests, right? Because that not only allows us to then change the field of the values for the status field, we could even go ahead and if you remember, we could only cancel if the order was still in this payment expected state, right? because someone was inspecting that status. And if we are in the status, let's say, prepared, with the previous logic, the client would not actually kind of foresee that it might still be able to cancel. But the business still might decide to, and I think, in fact, that's what you can do at Starbucks. You can just like still return your drink if you're not satisfied with it, even if after it's prepared, because they just assume that redoing it is less expensive than all kind of other measures they could put in there. If I follow that model, I could just on the server side decide that even in that, what was it, prepared state, I just add the link to the payload. And if the client was just like implemented in that, oh, if the link is present, then do that. If the link is not present, it would just automatically pick up that change in business process, right? I admit this is an idealized example, but that's what you try to find for talks like these, right? I'm not saying that it's the ultimate goal, like this kind of like self-learning clients picking up features left and right. The ultimate goal in the context of, to come back to that overall topic, in the context of microservices, is being able to deploy that new server and not breaking the clients. It's totally fine if you require a redeployment of the client to pick up the new versions, but like just breaking those is kind of recipe for disaster. So the ultimate principle in effect here is that we're basically, so we're simplifying decisions, right? We didn't have to tell the client anymore that it's, or details about here's the state of that order, and that state is expressed through a value of a certain field. We just told it, here's a link, if it's present, do that. If it's not present, do that. So it's a simple Boolean yes or no. So we're simplifying the decisions. And in fact, what we're doing here is we're trading two kinds of knowledge, two kinds of complexity against each other, right? So domain knowledge is knowing that the order can be canceled if it's in the state of payment expected. Protocol complexity is what I consider having to teach the client that links are expressed in JSON in a way, right? You have to be able to find links, you have to be able to follow links. You might even be able to, have to be able to expand link templates. So it's all kind of, let's say, more technical, more protocol-related stuff. Just to make this more graphical, so we have the non-hypermedia-based systems on this side and the hypermedia-based ones, right? So just assume we build a client that way or that way. In my first option was to put a lot of knowledge into the domain knowledge into the client, and it not having to actually be able to follow links in the first place, right? So a tiny amount of protocol knowledge. It just needs to know what JSON is basically, and the fields in there. And I'm kind of claiming that this kind of coupling to the server is basically resulting from that. And I mean, that's a claim in the first place, right? I could just have it's kind of like putting up a graphic that makes your point, really. So, but why is that? Why do I ultimately think this is true? If you think about it, when was the last time that the way a URI was structured changed? Sometimes in the 90s, like with the advent of the web, right? So it's kind of like URIs look a certain way, and there's an RFC for that, and it's very unlikely that this is going to change. When was the last time a business rule in your application changed? Yesterday, right? So if in doubt, wouldn't you actually rather like hard code more knowledge about stuff that doesn't change into your clients, or would you rather actually like build your client on volatile knowledge, really? Right? So that's kind of the trade-off. And it's not something that's like a flip switch. You do one or the other. There's a lot of things that come into play here, and it's something you can gradually move to, right? Just start like sprinkling links around and see how that actually feels to you and to the client developers. It's really something that you sort of have to get used to, and it's a certain way of thinking. But thinking in state machines, thinking in, okay, express a state transition as a link, that usually already helps quite a bit. There's, of course, help for building these kinds of systems in the Spring ecosystem. There's of course Spring HATEOAS that so far has supported HAL. Mostly we're in the process of adding support for more advanced affordances support. That's basically like putting these affordances into the representations and being able to express affordances so that they can actually be rendered in different media types, collection, JSON, HAL forms. Greg has built that recently. So that's going to come in a 1.0 version, hopefully pretty soon. There's also Spring REST docs, which is kind of like trying to, or it's basically raising the question, how do you actually verify that stuff in an API actually works? And it's also taking a refreshingly different attempt than any other tools that sort of try to sort of statically analyze your code. It's basically you write a test, against an actual executed HTTP request and response, and then it's basically sort of validating what you have documented or attempted to document in your test case versus what the client has actually received as a response. So it will also indicate that you forgot to actually document a certain field in the payload. And the tests failing would then break your build, and by that you sort of actually always sure that what you document is really what you have running or deployed really. That REST docs basically produces ASCII doctor snippets that then can be included in some ASCII doctor documentation, and that in combination with, I didn't mention Spring Data REST here, but there's a HAL browser that's pretty convenient to use to actually ship to, or to actually let the API be explored, and that could then include documentation generated by Spring REST docs. There's another project that Marcin is working on, Spring Cloud Contract. It's a tricky thing, and we're not really getting into fistfights, but there's been some disagreements on the way you'd be working with APIs, and that tool is very much targeted towards APIs that you have to sort of use, and you want to build APIs or you want to build tests that sort of check that you use them correctly. It's built around the consumer-driven contract approach, which I, as indicated before, am not quite sure is the thing you should actually try to pursue. Because of that, do you want to know the client's aspect, right? If you're in that situation, it's a brilliant tool to use. You can even make use of that in, let's say, more Hypermedia, more server-side driven APIs. In that RESTbox example I have on GitHub, we use it to provide wire mock stubs from the recorded Hypermedia interactions. So from the process flow, you can get wire mock stubs for the entire process flow, so that you can then use that on the client to actually test the client and don't need to have a server running. So it's useful in that world. It's very useful in the consumer-driven contract testing world. So definitely something worth checking out. So to round things off, high-level APIs over low-level ones. I think I got that point across. Hypermedia and late binding. Late binding meaning trying to be as lenient against changes in the document structure that you basically receive, and that over hard-coded URIs and interactions. So make your client aware of Hypermedia and just let it follow the links. Protocol knowledge over domain knowledge. That was something we got to in the very end, and test verified docs over docs derived from static analysis. With that, I'd like to thank you very much. I guess we'll still be around for quite a while if you have any questions. I hope you enjoyed the conference, and thanks for your attention.